Hey everyone, today we are going to be solving some multi-step equations. So we're going to be looking at equations that may take some steps before we get to that two-step part that we were working on last week. We're going to start off with just the distributive property. Then we're going to add in some fraction stuff. We're going to do some distributing with combining like terms, and then we're going to finish with some more complicated fraction problems. So with this example, I'm actually going to show it two different ways. So I'm actually going to rewrite this problem for a second time over here, just so I can show you a couple different ways that this problem can work. So remember that the distributive property is multiplication. So when I think about things that are multiplied together, I can undo part of that with division. So one thing I can do with these equations, if it allows for it, so of course they have to be compatible numbers in order for this to make sense. In this case, 2 times x plus 3 equals 14. The 2 and the 14 are compatible with each other. So I can actually divide by 2 on both sides to get rid of that distributive property if I want to. So I can have this be x plus 3 equals 7, remembering that I have to divide on both sides. So the 2's cancel here, and then 14 divided by 7 is 2. And then this becomes a one-step equation instead of a two-step equation. So I'm going to solve by subtracting 3 on both sides. So x equals 4. Now, say I didn't recognize that those numbers were compatible, or I just want to be consistent and use the distributive property every single time I do one of these problems. I'm going to distribute this 2 to the x and the 3. So this is going to be 2x plus 6 is equal to 14. And this one is truly a two-step equation at this point because I have distributed that positive 2. So I'm going to subtract 6. So 2x equals 8. And then when I divide by 2, x equals 4. So you can see that either way that I do it, as long as I'm distributing appropriately and doing my division appropriately, I'm going to get the same answer. Now in part B, when I look at this equation, 3 times x plus 4 equals 7, 7 divided by 3 is not something that I want to deal with. It's going to be an ugly fraction or a decimal, and I just don't want to deal with that. So this one I am going to distribute. So I'm going to do 3 times x and 3 times 4. So 3x plus 12 equals 7. Remembering to multiply by each part of that expression. So now I'm going to subtract 12 from both sides. So 3x equals negative 5. And then I can divide by 3. And I'm actually going to leave this as a negative 5 over 3. Because when the division does not work out, the fraction answer is the more accurate answer instead of giving a repeating decimal. So I'm going to leave that as a fraction. For C and D, we're doing the distributive property with fractions. And again, the same thing is going to happen here. Things might be compatible, and multiplying through with the distributive property is going to make sense. And sometimes it's not going to make sense to use the distributive property, and it's going to make more sense to clear that fraction. So in part C here, I'm actually going to use the distributive property, and then in part D, I'm going to show you how to clear the fraction. You can obviously choose to clear the fraction in every single one, because you're just going to be using multiplication. So I'm going to distribute here because I know that 8 and 4 are compatible with each other, and 16 and 4 are also compatible with each other. So 3/4 times 8 is going to be 6x, and 3/4 of 16 is going to be 12, and it's equal to 5. So I can see that when I multiplied through by those whole numbers, they came out as whole numbers. They worked out nicely for me to be able to solve a two-step equation. So now I'm going to add 12 to both sides, and 6x equals 17, and then I divide by 6, so x equals 17 over 6. And again, a fraction answer doesn't mean that you've done the equation wrong. It just means that that's how the solution came out, and it's probably true, okay? Now in part D, this time I'm going to show you how to clear the fraction. Because if I try to multiply 2/3 times 4 and 2/3 times 5, it's not going to come out very pretty, and I don't want to deal with fractions in my equation. So what I'm going to do is I'm going to surround the entire equation on both sides by parentheses, and I'm going to multiply by the denominator. And I'm only going to do the denominator to clear the fraction, because multiplying by the reciprocal is not necessarily going to be compatible with everything. So I want to make sure that I at least clear the fraction. When I clear the fraction, the 3's on this side are going to cancel, and I'm left with 2 times 4x plus 5 equals 48. And then we're back to a problem like part A. Part A, I had an even number outside of my parentheses, and I had an even number on the other side. So I can choose how I want to handle that multiplication. Do I want to get rid of it before I distribute, or do I want to distribute and then have to do a two-step? In this one, I'm going to choose to divide first. So I'm going to divide by 2, and I get 4x plus 5 equals 24. Then I'm going to subtract 5. So 4x equals 19. I divide by 4, and I'm going to leave it as 19 over 4. Okay? So that's dealing with just the distributive property. So whether you're distributing a whole number, you can make that decision based on the compatibility of the numbers. And then with fractions, you definitely want to make your decision based on the compatibility of the numbers. In example 2, we're talking about distributing and then combining like terms. So in this one, I am going to distribute first because there is that extra set of terms hanging out there. So like there's a plus 8, there's a plus 2. I have to distribute and combine like terms before I can think about doing anything else. So these ones you do have to distribute. So I'm going to distribute this -2 here. So -2x minus 6 plus 8 is equal to -20. Now I'm going to combine like terms. So -6 plus 8 is -2x minus 2 equals -20. And now I'm back to that two-step equation. So plus 2, -2x equals -18. And then I divide by -2, and x equals 9. Same thing over here. I'm going to distribute first because I got this extra like term hanging out here. So -3x plus 12 plus 2 equals -18. 12 and 2 is 14, so -3x plus 14 is equal to -18. Can subtract 14 from both sides, so -3x equals -32. And when I divide by -3, I get x equals, and I'm going to leave it as 32 over 3, but the negatives cancel out to be a positive. Okay. So there's that. So we've got distributive property and combining like terms. And now we're going to do some equations involving fractions. Now for these equations involving fractions, the first thing we are going to do is we are going to clear the fractions, what we call clearing the fractions. We're going to get rid of them. So we are going to choose a number to multiply by that is compatible with all of the denominators. So between 4 and 10, I'm actually going to choose to multiply by 20. There are other numbers that you could multiply by. Okay, don't get me wrong. There are other numbers that you can multiply by. But 20 is going to be the smallest one. And what I'm going to do here is I'm going to multiply each part of my expression by 20 over 1. So essentially doing a humongous distributive property. So this is going to be -1 over 4x times 20 over 1. 3 over 4x times 20 over 1. Minus 3 over 10 times 20 over 1 equals 7 over 10 times 20 over 1. And I'm going to do all of that cross-canceling. So this is a 1, this is a 5. This is a 1, this is a 5. This is a 1, this is a 2. This is a 1, this is a 2. So I'm going to have -5x minus 15x minus 6 equals 14. And just by getting rid of all of those fractions, this equation looks so much less ugly. It looks so much more manageable. So now I'm going to combine my like terms. So negative 20x minus 6 equals 14. And then I can add 6 to both sides. So negative 20x equals 20. When I divide by negative 20, x equals negative 1. And even the solution is not so bad when I get rid of those fractions. I'm going to use the same number on part B. So I'm going to use 20 again because 4, 5, 2, and 10 all work with 20 over 1. So I'm going to have negative 1 over 4x times 20 over 1 plus 2 over 5 times 20 over 1 minus 9 over 2 times 20 over 1 equals 7 over 10 times 20 over 1. And again, I'm going to do all that cross-canceling. So 1 and 5, 1 and 4, 1 and 10, 1 and 2. So negative 5x plus 8 minus 90 equals 14. I can combine like terms here, so negative 5x minus 81 equals 14. I add 81 to both sides, and negative 5x equals positive 95. And then I'm going to divide by negative 5. Is going to be negative 19. Okay, so when you come to these equations that have all of these fractions in it, now if I look at these equations, they all have fractions all the way across. It's all fractions. I want to clear those fractions first. Okay. So when I look down here at part C, I'm going to multiply by 28 over 1 because 28 is going to be compatible with 28. It's also going to be compatible with 2, 4, and 7. And then here, 9, 3, 4, and 12, I'm going to use 36 over 1 to help me clear that fraction. So negative 3 over 7x times 28 over 1 plus 3 over 4 times 28 over 1 minus 1 over 2x times 28 over 1 equals 5 over 28 times 28 over 1. And then I'm going to go through and cross cancel. So 1 and 4, 1 and 7, 1 and 14, 1 and 1. And I am left with negative 12x plus 21 minus 14x equals 5. Okay, so just by clearing those fractions, I make it look a little bit more manageable. I'm working with all those whole numbers now. So negative 12 and negative 14 is going to be negative 26x plus 21 is equal to 5. I subtract 21 and I get negative 26x equals negative 16. So when I divide by negative 26, I get x equals 8 over 13. And I simplified that fraction. For the last one, I'm going to have negative 5 over 9x times 36 over 1 plus 1/3 x times 36 over 1 minus 3 over 4 times 36 over 1 equals negative 7 over 12 times 36 over 1. So for all my cross canceling, 1 and 4, 1 and 12, 1 and 9, 1 and 3. So negative 20x plus 12x minus 27 is equal to negative 21. So negative 8x minus 27 is equal to negative 21. So I'm going to add 27 to both sides. So negative 8x equals 6. I divide by negative 8, and I get x equals negative 3 over 4. It is okay for our answers to come out as fractions. They don't have to be a scary thing. It's just that clearing those fractions from the very beginning is going to allow us to work with whole numbers until we get to that fraction answer. Okay, so we started off with the distributive property. I've given you a couple of different options with the distributive property. And then we did distributive property with fractions. And again, I gave you a couple different options with that as well. And then we worked our way into distributing and combining like terms. On those ones, we're going to distribute first for sure, because there's going to be things that we have to combine. And then on this back side here, we are looking at how do we clear the fraction to make our lives a little bit easier. Even if we're going to get an ugly fraction answer, working with those whole numbers is going to be a little bit simpler.